With Lecture 5, we bring ourselves to this concept of reciprocal altruism. We've already talked about how seemingly altruistic behaviors can be favored, certainly among close kin, as explained by Hamilton's rule and the idea of inclusive fitness. But now we're going to address how cooperation might emerge among individuals who aren't related. And so remember that last time we discussed how cooperation can occur among genetic relatives, that we've got this concept of inclusive fitness where your actual fitness doesn't simply depend on the function that a particular trait plays in your own direct reproduction, but also how those traits may impact genetic relatives' reproduction. And so you share a certain proportion of your genes with your genetic relatives, and you might make different decisions based on the closeness of the degree of relation between you, or that value of R, the coefficient of relatedness. How then do we explain cooperation among individuals who are not related at all? This is really an interesting topic, particularly with regards to humans, because we spend so much time in our lives surrounded by people who aren't really that closely related to us. I mean, we've constantly been a species expanding our boundaries. We've constantly come in contact with people who are different from us. We form long-term affiliative relationships that we call friendships with people who are not our genetic relatives. So how are we able to explain this and still view evolutionary theory as relevant? There are a couple of ways in which we can explain cooperation. And we hinted at some of these as we looked at that graph of what we call a trait space, how you can have these dyadic interactions with the payoff to the actor being, or the donor being, either positive or negative, and the payoff to the recipient being either positive or negative. And so we talked about how there's cooperation, there's selfish behavior, there's altruism, and there's spite. So this we spent lecture 4 talking about kin selection, which is a form of cooperation because we do end up seeing a long-term mutual benefit to both parties. We can also have cooperation occur due to mutualism. This is where there's a net survival or reproductive benefit to both individuals, whether or not those individuals are related. And so when we talked about this behavior that dolphins do of forming these bubble nets, this is a really good example of mutualism. When we look at cleaner fish and the sharks that they may feed upon, that is another good example of mutualism. I mean, the reason that the feeder fish engage in this particular behavior is because they get a free meal out of it. The reason the sharks tolerate this particular behavior is because they get better health, whether it's dental hygiene for the fish that actually go into their mouths, or whether it's the removal of ectoparasites for the fish that don't. We can also see cases where there's manipulation. And so this is where it appears that the donor is engaging in altruism, but in reality, it's the recipient that's manipulating their relationship. And so this is that example with brood parasitism, that we haven't seen evolution favor the development of a mechanism that allows these birds that are parasitized to recognize their own offspring versus the offspring of the bird who's parasitizing them. And so it's really the brown-headed cowbirds and the cuckoos who are manipulating the behavior and kind of co-opting and taking advantage of the behavior of the species in whose nests they lay their eggs. And then lastly, we have reciprocity, which is what we're going to spend the rest of this lecture discussing. True altruism requires that the donor pay a cost so that the recipient gains a benefit. We consider an altruistic relationship reciprocal when the donor and the recipient change roles sequentially. And so the idea that I will bear a cost at this present time in order to give you a benefit. However, I have the expectation that sometime in the future you are going to bear an equivalent cost to give me an equivalent benefit. So, we can think about what happens when you go out with your friends. Okay, so you go out with your friends. You've got someone who forgets their wallet one time. What might you do? Well, you might cover the cost of their tab, so that they're still able to go out and enjoy themselves with you. But generally, when you're covering the cost of your friends, when you've gone out, you have this expectation that at some point your friend's going to pay you back, whether it's through some other favor they may do for you, whether it's through being paid back absolutely in kind. It's this hope that you will recoup that cost that you paid at some future moment in time. And so this is just kind of a casual example of reciprocity, but reciprocity is something that we engage in pretty much every day with people that we have affiliative relationships with friends, with acquaintances, etc. And so reciprocal altruism was first proposed to explain the cooperation among non-kin, and Trivers, the gentleman who wrote those supplemental chapters that we read last week and the first week, is credited with the first explicit definition or discussion of reciprocity. And so the definition of reciprocity is that you pay cost C today to confer a benefit B to the recipient today, and that you will receive benefit B in the future from the recipient who pays cost C in the future. So we can also define this then as the non-simultaneous exchange of resources. Now, when we're discussing reciprocity, one thing that we're going to talk about is that's really important in driving this process is an asynchrony in abundance and need. And so if everybody has access to the exact same, let's say, quantity of resources or of benefit or whatever, we're not going to see reciprocal systems emerge. It is this non-simultaneous exchange that is a critical part of this, and that we have perhaps asynchronous changes in values of behaviors and or resources as well. And so we'll keep discussing this with some of the criteria that have to be met for reciprocity to be able to emerge. And so we talked in that learning and behavior lecture about the fact that we can often intuitively understand like diagrams of relationships, particularly social exchanges, even if we don't necessarily have a good concept of the math that gives rise to these relationships. And I'd mentioned in that lecture that we were going to start this week talking about something called diminishing returns curves. What I've drawn here is a diminishing returns curve. And the reason diminishing returns curves are so important is because they really get at how behaviors, how resources, etc., can change in value based on how long you've been engaging in those behaviors, based on the quantity of resources that you already possess. And so we have over here on the left graph, we have a change in value of 2 units. This idea that you might go from possessing 7 units of a resource to possessing 5 units of a resource. Why might you change in value? Well, because you've perhaps shared those resources. You've given some away. And it is the shape of this curve that is what we call the diminishing returns curve. The idea behind the diminishing returns curve is that you've got unequal slope depending on where you find yourself along the curve. And so we can think about resources or time allocation in this way. Think about this idea of McDonald's hamburgers. Okay, when you have already consumed 7 McDonald's hamburgers, giving up two of them isn't going to really result in that much loss in value, because you've got kind of a maximum rate at which you can assimilate some kind of benefit, nutritional benefit from the food that you eat. If you eat too much food in one sitting, it doesn't translate into like a higher metabolism level. It doesn't translate into being able to use more food and being able to perhaps infinitely increase your energy budget. We have constraints in how we convert food to energy, to reproduction, based on our underlying fundamental biology. So if you possess 7 hamburgers, chances are you aren't going to be able to absorb the nutrients from 7 hamburgers. So when we have this change in slope based on the amount of time or the quantity of something that you possess, we're also going to have a corresponding change in value, and that is what is depicted here. So you can see that the slope of your relationship is very, very steep at the beginning of your relationship when you have a very small amount of that. But as you move out along the curve to having either a greater quantity or having spent more time at something, that slope diminishes. We can look at the change in the y-axis given a correspondingly corresponding incremental change in the x-axis, and that is what gives us our value. So right here we change by 2 units pretty far out on the x-axis, and this results in us only giving up a value of this amount here on the y-axis. Look at what our situation might be later. Later, when we have nothing, if we see an incremental increase in 2 units, because we're very, very early in this curve, we are very, very early in this x-axis, that same incremental change of 2 units is going to result in a really big value to us. And so thinking back to a McDonald's hamburger example, when you have not eaten at all that day, or let's take it a step further and say you haven't eaten in several days, the value of those initial 2 hamburgers that you're going to consume is very, very great. So when you possess very little of a substance, when you contribute very little time allocation to a particular behavior, quite often you get a really big bang for your buck. It's worth it. You end up getting a pretty big benefit. When you are pretty far along the curve and you've already either consumed a lot of that resource, or have possession of that resource, or perhaps spend a lot of time engaging in a particular behavior, you're going to get a very small payoff. And so, the food is one good example of this because of our constraints, because we can't just infinitely absorb nutrients from our food. But we can also think about other behaviors that we engage in on a fairly regular basis that would also have this benefit. We've seen a curve like this when we talked about copulation time in dung flies, relating that value along the x-axis is the proportion of eggs that a given male's sperm fertilizes, and then that x-axis is time spent in copulation. So spending a few minutes in copulation, if you haven't yet copulated with that particular female and she has not oviposited, it's going to give you a very, very big benefit in terms of the proportion of her eggs that you fertilize. The farther you go along, the longer you spend in copulation, that benefit is going to diminish. Similarly, we could think about the time that you spend studying for exams. We'll have our first exam in this class in week 4. The first hour that you spend studying for exams gives you a really big payoff. If, however, you've been studying for exams for, let's say, 20 hours, increasing your study time by 1 more hour isn't going to give you that same corresponding benefit. So studying for exams has a diminishing returns curve relationship. Time spent with romantic partners, potentially in terms of how you foster and grow your relationship, can have a diminishing returns curve. Anything that is really this time allocation problem. We don't often see continuous payoffs that don't diminish the longer that we spend time doing something. So we have an asynchrony in the value of that same incremental amount of resources, such that if we are very early in the curve, an incremental increase in resources will give us a really big payoff. If we are far along the curve, an incremental increase in resources will give us a very small payoff. And so Trivers stated that reciprocal altruism will be stable and favored by natural selection if the following criteria are met. The first is that we have to have this asynchrony of abundance and need of time or resources. This is precisely what the diminishing returns gives us, is an asynchrony in abundance and need. And so this is why understanding the diminishing returns curve and the relationship that it depicts is so important for the scope of this class, because this certainly characterizes a lot of behaviors in which we engage. It characterizes how food resources are turned into fitness benefits, how time allocation can be turned into fitness benefits, etc. Secondly, the benefits need to outweigh the cost to both individuals. And so this is facilitated by this diminishing returns curve and this asynchronous change in value over time. Generally, if we go back to the previous slide, when we're giving up a quantity of resources, we have a lot. We're far out along the x-axis. So the value or the cost that we're paying is very small. We compare this to the benefit of the resources or time that we may get if we are early in the curve. And this overall benefit, if we add what our payoff would be up to that cutoff point to what we'll get as a benefit later, it almost always outweighs the cost. And so these asynchronous changes in value over time set the stage for the benefits to be able to outweigh the cost for both individuals. However, for benefits to outweigh the cost, we have to, and for reciprocity to work, we also have to make sure that we are going to be interacting with the same individuals at a later date. And so we need to specifically have many future interactions over an unspecified time. So there are certain life history features. I know we haven't broached yet what we refer to as life history theory, but life history features are features of your life course that correspond with that dramatically affect fitness. So things that can affect survival and or reproduction. And so in terms of reciprocity, one thing that would favor the development of reciprocal relationships because of having these future interactions is having a long lifespan. We're not going to see reciprocity emerge in Drosophila, for example, who have a lifespan of about 10 hours. We may see reciprocity emerge among great apes, who have a lifespan of 50 to 60 years, among dolphins, who have a lifespan of 80 or so years, among elephants, who have a lifespan of 80 or so years, and certainly among humans, who have a maximum lifespan of 121 years. The other life history feature that correlates with these future interactions over an unspecified time is low dispersal rates. This doesn't mean that we don't have gene flow out. This doesn't mean that we have a lot of inbreeding or anything like that. It simply means in the way that many animals cope with the need to minimize inbreeding, but also the desire to have long-term relationships that correlate with fitness benefits, is that dispersal might be biased in one sex. So we talked about ground squirrels and their alarm calls already. And in that context, half of the individuals in a troop are going to be related because the females all stay in their natal territory, in their natal troop. Half of the individuals are thusly going to be unrelated, and that's going to be the males that migrate in at puberty. And so this dispersal pattern in which only one sex disperses is quite common among, for example, higher primates. It varies based on whether we're talking about monkeys or apes, and the payoff to having tightly bonded males versus tightly bonded females. Depending on species typical characteristics, depending on the particularly ecology that these primates find themselves in. So, for example, baboons, females remain behind in their natal troop, males disperse at puberty. By contrast, for chimpanzees, males remain behind in their natal troop, females disperse at puberty. But the overall effect is that we've got low dispersal of at least one sex, which gives us then ample opportunities to recoup the costs that we've paid by aiding an unrelated individual. The fourth criteria here is this ability to detect cheaters and withhold benefits from them. One of the reasons why songbirds haven't been able to detect the eggs of the species that parasitize them, like the brown-headed cowbirds and the cuckoos, is because it's not. They're not doing this because of mutualism or because of reciprocity. They're being manipulated by the recipient of that benefit. They're being manipulated by the species that parasitize them. And so, with this ability to detect cheaters, with this ability to withhold benefits from them, we can also detect opportunities for reciprocation. So, think back to this example that we used of you've got a friend, you guys are all going out, either it's not payday yet for that friend or they've forgotten their wallet. What do you do that first time that you have resources and they don't? Well, that first time you're probably going to help them out. Now, what if that turns into a frequent repeat behavior? What if every time that you go out, that friend conveniently forgot their wallet at home or hasn't been paid in 2 weeks or whatever the excuse might be? Well, eventually, because of what we call free riding or basically being taken advantage of, you're going to stop offering to that individual. Now, whether that means that you simply say, oh yeah, no, I can't help you, or it means that that person is no longer invited when you go out with your friends, you're able to detect this unfairness. You're able to detect this kind of differential cost and benefit structure that isn't lending itself to reciprocity, and you're very quickly going to take social means to prevent that free riding in the future.